Black Sea, what really lies beneath its surface. We are used to looking at the sea from above, at the shimmer of the water, at the white strip of surf, at boats, dolphins, seagulls, and the shore that seems like an extension of summer. But if you lower your gaze deeper, the picture changes very quickly, because beneath the surface of the Black Sea, another world begins. And it is so different from the upper one that they could almost be considered two separate seas. Above, oxygen, light, and life. Below, darkness, hydrogen sulfide, and an almost complete absence of complex organisms. Moreover, the lower layer occupies most of the sea's total volume. It creates a strange picture. We stand on the shore of an ordinary warm sea, and beneath us, at depth, begins a giant oxygen-free zone, one that has existed for thousands of years. But this is only the first mystery, because it is precisely thanks to this dead water that the Black Sea preserves things that have long disappeared in other seas. Lying on its bottom are the remains of ancient ships. Some of them have survived for over 2,000 years. Wooden hulls, ropes, rigging details. What would be gradually destroyed by organisms in ordinary seawater has been preserved here. Why? How did an ordinary sea turn into a giant time capsule? Where did the poisonous layer come from? And why is the Black Sea structured as if nature divided it into two floors? To answer these questions, we must first forget everything we know about the sea and look at it not from above, but from the side. Imagine an ordinary glass of water. If the water in it is still, it remains just water. But now imagine that the glass contains two liquids of different densities. One is lighter, the other is heavier. They can exist one on top of the other, forming a fairly stable boundary. Something similar happens with the Black Sea. A huge amount of fresh water flows into it from above. The Danube, the Dniester, the Dnieper, other rivers. This water contains less salt and is therefore lighter. It stays in the upper part of the sea. And from below, through the Bosphorus, saltier water flows in from the Mediterranean Sea. It is denser, and it tends downward. The result is a very unusual system. Fresh and less salty water remains on top. More salty water stays below. Between them there is a transitional layer. And the most important thing here is not the boundary itself, but that it prevents the water from mixing normally. In most seas, mixing happens constantly. Wind pushes the surface, waves churn the water, temperature changes, water of different densities moves up and down. As a result, oxygen from the surface can gradually penetrate deeper layers. But the Black Sea is very deep. Its surface can be stirred by a storm. A wave can be raised, the upper layer can be mixed. But this mixing does not reach all the way to the bottom. And here begins a chain that explains almost everything. Life on the surface constantly produces waste. Microscopic organisms die. Algae die off, animals perish, organic remains gradually sink downward. In an ordinary sea, they decompose in the presence of oxygen. But in the depths of the Black Sea, there is almost no oxygen. So a different chemistry begins there. Microorganisms continue to break down organic matter. Only now they use other chemical reactions. And one of the results of this process is hydrogen sulfide, the very gas we recognize by the characteristic smell of rotten eggs. But at great depths, the smell cannot be detected, because there is no air there to carry it to us. Hydrogen sulfide is simply dissolved in the water, and gradually there is more and more of it. Why doesn't it disappear? Because there is no main mechanism that could remove it. There is no full mixing. Not enough oxygen comes from above, and all this mass of water cannot rise from below. It creates a kind of trap. Organic matter falls down. Microorganisms process it. Chemical compounds form. And all of this remains in the depths, year after year, century after century, millennium after millennium. This is how the vast oxygen-free zone formed. Now a strange question arises. Why do we even call this water dead? After all, bacteria live there, and life in the depths does indeed exist. It's just structured differently. Fish need oxygen, crabs need oxygen, mollusks need oxygen. Most of the complex organisms we are familiar with need it too, but some microorganisms are capable of obtaining energy through completely different methods. So the word dead here does not mean the absence of all life. It means the absence of the complex ecosystem we are accustomed to. And this is a very important distinction, because it is precisely this that will lead us to the ancient ships. Imagine a wooden ship. It sets out to sea. On it are people, cargo, ropes, masts. Then an accident happens. The ship sinks. A few hours later, no one sees it anymore. A few days later, it ends up on the bottom. And then begins a process familiar to marine archaeology. Wood becomes food. First, microorganisms inhabit it. Then come organisms that can gnaw through wood, mollusks, shipworms, other invertebrates. Gradually, the structure loses strength. Waves and currents break it apart. Sediments bury the remains, and after a sufficiently long time, only a trace may remain of the wooden ship. But now imagine the same ship in water, where there is almost no oxygen. Organisms that normally destroy wood cannot survive there properly. One of the main mechanisms of destruction disappears, and the ship ends up as if sealed. Not because the water preserves it, but because the water does not allow the usual system of destruction to work. These are fundamentally different things. The Black Sea did not stop time. It simply turned off some of the processes that usually measure that time. And here appears the first real find. On the bottom of the Black Sea, researchers have discovered ancient ships preserved much better than could be expected. Some finds date back to the ancient period, and it is not just a few fragments. Structural details are preserved, hull elements, traces of cargo, items that would have long disappeared elsewhere. For an archaeologist, this is almost an incredible stroke of luck, because an ordinary ancient ship often has to be reconstructed from a few fragments of wood. Here, the environment itself becomes part of the archaeological tool. Depth hides the object. Anoxic water protects it from some destructive organisms. Sediments gradually cover it, and the ship can remain there for centuries, until one day, man comes for it again. But if the Black Sea is structured like this now, the next question arises. Has it always been like this? No. And here the story becomes much older than the ships themselves. We have to go back about 7,500 years. At that time, the Earth's climate was already changing after the last ice age. Huge masses of water that had been in glaciers were returning to the ocean. The level of the world ocean was rising, and the geography of some regions was gradually changing. In the area of the modern Bosphorus, there was a land bridge that separated the Black Sea basin and the Mediterranean Sea. But if the sea level on one side continues to rise, one day there comes a moment when the water is higher than this barrier, and then a completely different question arises. What happens when the ocean gets a chance to break into a huge enclosed basin? This is where one of the most famous hypotheses in the history of the Black Sea begins. According to one scenario, the Mediterranean Sea broke through the Bosphorus into the basin of an ancient freshwater lake. The flow of water was enormous. Before it lay a low-lying area that gradually went underwater. If this version is correct, for the people living on the shores, it must have been an event of colossal scale. Imagine a settlement. Yesterday before it, a familiar shore. Today, the water creeps closer. After a while, the low-lying areas disappear. Then the shoreline recedes. The river that used to flow into the lake becomes part of a new marine basin. Salt water appears. The fish change. The vegetation changes. The entire ecosystem changes. But the most important thing happens below the surface. Heavy salt water sinks down, and lighter fresh water remains above. Thus appears the foundation of that very two-layer system that we see today. Here an important caveat must be made. The scale and speed of this ancient event remain a subject of scientific debate. There is a scenario of a sudden catastrophic breach. There are models in which the changes occurred much more slowly. Therefore, one cannot honestly say, we know for sure that 7,500 years ago, a giant waterfall of exactly such and such power occurred. This cannot be asserted as an established fact. But the sequence itself, the change in sea level, the connection of basins, the inflow of salt water, and the formation of modern stratification, is the key to understanding the history of the Black Sea. And here another puzzle arises. Why did this story become connected with legends of the Great Flood at all? If a great flood did occur during a period when human communities were already living in the region, it could have left a trace in collective memory, not necessarily in the form of an exact account. First, there could have been a real experience, then a story passed on to the next generation. After hundreds of years, details change. After thousands, the original event turns into a myth, and therefore a hypothesis emerged that the memory of the ancient change of the Black Sea could have somehow influenced some flood legends. But here it is especially important not to confuse an interesting possibility with the proven origin of a specific legend. The connection is discussed, it is not definitively established. And this is where the special charm of science lies. Sometimes the most honest ending to a story is not, here is the exact answer, but rather, here is what we know, and here is where the unknown begins. But let us return to the present, because ancient history explains not only the past, it explains what is happening to the Black Sea right now. Look at its map, a huge basin, great depth, many rivers, a narrow connection to the Mediterranean Sea. On the surface, familiar marine life. But most of the water lies below a layer that constantly receives oxygen. This means that the entire ecosystem essentially lives on top, as if a vast ocean were divided by a horizontal boundary. Above, a layer of water suitable for complex life was left, and everything else was turned into a chemically completely different environment. And this boundary is not static. Why is this important? Because the state of the upper layer depends on what enters the sea from the land. Rivers carry not only water, they carry nutrients, including compounds of nitrogen and phosphorus that are used in agriculture. Under certain conditions, an excess of nutrients can stimulate the growth of algae. At first, this seems like good news. More plants, more life. But then, the plants and organic matter die off. They begin to decompose. Microorganisms need oxygen for this. And the more organic matter sinks down, the more oxygen is consumed. If it becomes too scarce, the zone suitable for ordinary marine life may shrink. And then what happens on the surface begins to change conditions deeper down. This creates a paradox. Humans may see no catastrophe at all. The sea still looks blue. The waves still break against the shore. Fish can still swim near the surface. But the chemical balance inside the vast basin may gradually change. And here we can finally understand the true strangeness of the Black Sea. Its main feature is not just depth, not just salinity, not just hydrogen sulfide, and not even the ancient ships. The main thing is the boundary, a boundary between two states of water, between oxygen and its absence, between familiar marine life and the microbial world, between modernity and the archaeological past. And this boundary exists thanks to a whole chain of causes. Rivers bring fresh water. The Mediterranean Sea brings saltier water. Different densities separate the layers. The separation prevents deep mixing. Organic matter sinks down. Microorganisms process it. Oxygen is consumed. Oxygen-free conditions form. Hydrogen sulfide appears. And the absence of oxygen changes the very rate at which organic materials decompose. One cause, then another, then a third, and in the end we get a sea that is simultaneously alive on top and almost lifeless below. But the most surprising thing here is not even the chemistry. It is time. Imagine you are descending to the bottom. First, light disappears, then pressure changes, then familiar sounds fade, then oxygen runs out, and before you lies water that can preserve traces of people who lived long before the appearance of modern states. You look at a wooden structure. Once it was a ship. There were people on it. They had goals, goods, fears, ordinary life. They did not know that thousands of years later, their ship would become an archaeological object. They simply sailed across the sea. Then the sea took the ship, and the sea itself preserved it. We often imagine archaeology as working with the ground. You need to dig up a layer of soil, find a foundation, a coin, a potsherd, a grave. But the Black Sea shows a different version of archaeology. Here the water itself becomes a layer of history. The bottom turns into an archive. Sediments become pages, and the absence of oxygen acts as preservation. And this allows researchers to look into the past much deeper than seems possible. You can study not only ships, you can study deposits, chemical composition, remains of organisms, environmental changes, traces of ancient shorelines. All of this helps reconstruct the history of the basin. It turns out that the Black Sea is not just a place where ancient ships are preserved. It itself is a historical document. And all of this begins with a simple thing. With water of different densities. It seems incredible that such a simple physical difference can change an entire ecosystem. But that is exactly how nature works. Big consequences do not always start with big events. Sometimes everything begins with a small difference in density, with a thin layer, with the fact that two masses of water do not want to mix. Then time passes, thousands of years, and a small physical difference turns into a huge chemical system, a system that affects life, archaeology, history, and perhaps even human memory. So the next time you see the Black Sea, try to imagine it differently. Not as one huge blue surface, but as a vertical world. Above, light, wind, waves, fish, people, ships, and below, water with almost no oxygen. Even lower, a chemical environment where hydrogen sulfide accumulates, and where, possibly, lie traces of people we will never see, because the sea separates them from us not only by distance, but also by time. And perhaps that is precisely why the Black Sea is so unusual. This is not just a sea with unusual chemistry. It is a place where physics turns into biology, biology into geology, geology into history, and history returns again to people. We look at the surface and see the sea, but beneath that surface lies an archive thousands of years old. And the strangest thing about it is that the archive keeps changing. While waves roll above, chemical processes continue below. While people build new ships, old ones lie in the darkness. While we argue about how quickly the ancient sea changed, the sea itself continues to preserve evidence of that change. So the main question here is not just what lies on the bottom. The main question is, what else are we still unable to see? Because the Black Sea reminds us of a simple thing: the surface almost never tells the whole story. Sometimes to understand a place, you need to look deeper, much deeper.